Hi, welcome to Lesson 8, Contact versus Non-Contact Forces. This is a distinction that you may have learnt about at GCSE. Just like to take a moment, what's the difference between a contact and a non-contact force? The answer is, all forces are non-contact force. Nothing ever really touches. We talked yesterday about how my finger never touches the hand. Yeah, that's true of every force. And it frustrates me that this distinction is taught still because there's no such thing as a contact force. All forces are action at a distance. What would it mean for two things to touch? Well, I guess we'd mean that the masses got next to each other somehow. They were occupying the same bit of space-time. Now, you've already learnt about the strong nuclear force, so just think for a moment, how close do things tend to get inside the nucleus? Pause the video, just have a little think, see if you can remember. The answer is that the strong nuclear force kicks in around 3 femtometers and becomes strongly repulsive at around the half a femtometer level, so between a femtometer and half a femtometer. So nothing's ever really touching. As they get closer and closer, under a femtometer, under half a femtometer, the strong nuclear force is going off to infinity. They're never quite touching, are they? Nothing ever really touches anything else. A more interesting question, I think, comes from how quickly do non-contact forces happen? And here we get into some really fun physics. I'd like you to imagine a tube completely filled with marbles. And each marble is touching, for a given value of touching, each of the marbles next to it. It's all completely closely packed in. You can't get any more marbles in. And this tube is very, very long. In fact, it's a light year long. So if you don't remember, a light year is how far light travels in a year, so a very, very big distance. You take one marble and you push it in the end of the tube, and as you do, all the marbles move up one. How long does it take for the marble at the other end to pop out once you've pushed a new marble in? So it's a light year long, you push one marble in, they all move up one, and the marble pushes out at the end. Pause the video, have a think. Well, the first answer you might come to is it happens immediately, because that's tend how we think about pushing things. You start pushing one end of something and the front moves immediately. But it turns out that's not the case. It turns out forces spread at light speed. They spread at the speed of light. So therefore, if you push a marble in one end, it will take an entire year for a marble to pop out the other end, as the force spreads through the marble. Some people don't even think about it in terms of forces. They think about it in terms of information. It seems that information itself spreads through the universe at light speed, and that you can't affect things outside of your so-called light cone. But what is your light cone? I hear you cry. Well, here is a picture of one. So I think we've all explained it there. I'd like you to imagine a 4-dimensional cone, so that's 3 spatial dimensions in time, yeah? And this, where you are, is one point in 4D space-time, so it's a given place in the universe and a given time in the universe, yeah? And what you've got behind you in the light cone, so time is going this way, is everything that could possibly have affected this moment in time. So this is things 1 minute away, previous in time, that are also 1 light minute away. Same on the other side. Here might be half a light minute away, and it happened within half a minute. And as we get closer and closer to this point in space-time, the number of things that could possibly have affected it get narrower and narrower and narrower. Something over here, if we put an X here, that would be too far away and too close to you in time to have affected you in the now. You then have your one moment of space-time, and then everything that you could possibly affect spreads out into space-time in front of you, again at the speed of light. So what does this mean? Well, if we think about the sun, it's 8 light minutes away. So let's say that we'll put the sun here, and then we'll track it back in time to where it enters your light cone, and this here will be 8 minutes. So, if the sun did something 9 minutes ago, that can affect you in the here and now. But if it did something 4 minutes ago, it can't, because it's outside of your light cone. It's going to take 4 more minutes for all that information from the sun to catch up to you. We already know that if the sun were to explode right now, it would take 8 minutes for that information to get to us. So we can just start to think about that a little bit more sophisticatedly. Exactly the same way, if you've got a big laser that you're going to destroy the sun with, you're going to have to wait 8 minutes before anything you can do now could possibly interact with the sun. It's going to have to get inside your forward light cone before you can affect it. So there you go. Light cones. Far more interesting than contact and non-contact forces, I find. Something to muse on over the weekend. See you next week. Stay safe.